welcome back to my YouTube channel. I hope you have been enjoying all my previous videos. I just want to say a very big thank you to all my viewers out there for your full support. Now in this video, we want to discuss about glycolysis, and these are the sequence we follow. In this sequence, most especially in this video, I will look at the introduction to glycolysis, then the transport, then the glycolytic pathway. In this video, I will be looking more of the energy investment phase, but in my next video, I will look at the energy yielding phase and the alternative phase of glycolysis. Now, let's get right into it. Sequence is introduction to glycolysis. We want to look at what glycolysis is all about. Now, when we are talking of glycolysis, if you remember in my last video, when I explained beta oxidation, I talked about metabolism. When we talk about metabolism, is the sum of all biochemical changes that is occurring in living cells. So when we talk about metabolism, it is divided into the catabolism and the anabolism. Now, glycolysis falls in a catabolic pathway. Glycolysis is a catabolic pathway whereby a series of glucose is broken down to become what is called the pyruvate, which will later generate energy in the form of ATP. So glycolysis is a catabolic pathway. It is an endogenic reaction in the sense that during the process, energy is what? Liberated. Do you get it? Is liberated in what? In glycolysis. That is what glycolysis is all about. So our primary aim of glycolysis is to convert glucose. You get glucose is a monosaccharide. So we want to convert glucose to what is called 2-pyruvate. You get, so that is what glycolysis is. And the main reason why we undergo glycolysis is to generate cellular energy. You know, we need energy to ensure continuity of life. So where is this energy coming from? It can come from the process of what? Glycolysis. So in glycolysis, when we consume any kind of food, most especially carbohydrate-driven food, the carbohydrates become broken down by digestive system into what? Sugar or glucose, and the glucose diffuse into the what? Blood. So when the glucose diffuse into the blood, the glucose is preparing themselves for what? Glycolysis. Do you get? So the blood absorbs those what? Glucose, preparing for the process of what? Glycolysis. So when the body demands energy, that is when the body will devise a method called what? Glycolysis, to generate energy in the form of ATP for the cellular organism to what? To use. So that is what glycolysis is. So in glycolysis, we want to convert, we want to undergo the breakdown of glucose to 2-pyruvate coupled with the release of energy in the form of ATP. And I want you to know that glycolysis occurs in the cytoplasm. Yeah, it occurs in the intracellular fluid, in the cytosol of all living cells. That is where glycolysis was occur. Now let's think of it. We already know that glucose is absorbed in the blood. Do you get what I'm saying now? So this is a cell that will lead me to my next sequence, which is transport mechanism in glycolysis. We want to look at how glucose that is present in the bloodstream, how they become diffused into the what? Intracellular fluid, into the cytosol of living cell. That's what we want to look at in my next sequence, transport mechanism. Now, this is a cell. You get? So this is a cell. This is what we call the cytoplasm of the cell. Then outside the cell, what do we have? We have the extracellular fluid, which can be the what? The blood. Do you get it now? So outside the cell is the what? Extracellular fluid, which is the blood. So in this blood stream, there's presence of what? Glucose. I get what I'm saying now. So the glucose that is present in the bloodstream needs to diffuse into the what? Cytosol of living cell, where they undergo the process of what? Glycolysis. So how can this glucose diffuse into the cytosol of the living cell, which is the intracellular fluid? Now there is a two transport mechanism at which glucose can be used to diffuse into the cytosol of the cell. The first transport mechanism is called the sodium independent facilitated diffusion. Yeah, so this is the first transport mechanism at which glucose can use to diffuse into the cell. So the second one is the sodium dependent co-transport system. Yes, so these are the two mechanisms at which glucose can use to gain entry into the cytosol of the cell, which I'm going to be looking at. Now, so let's go into it. So the first one is sodium independent facilitated diffusion. Now, from the word facilitated diffusion, what does that mean? Facilitated diffusion is a type of diffusion that require assistance. So there are kind of the molecules that assist the glucose to diffuse into the cytosol of the living cell, which is the word intracellular fluid. So this is the intracellular fluid, the word the cytosol. How you get what I'm saying now? So in the sodium independent facilitated diffusion, there are some molecules, do you get what I'm saying now, that will diffuse the glucose inside the cell. That's what we call the glucose transporter. We call them GLUTs. Do you get it? Yeah, GLUTs. Glucose transporter. Do you get it now? So the glucose transporter undergo facilitated diffusion and transport glucose into the what? Into the cell. Are you getting my point now? That is about the what? The facilitated diffusion. And the glucose transporter are 1 to 14 in number. Do you get it? They are isoform in nature. But the glucose transporter we'll be using in glycolysis is GLUT 1 to 4. Do you get it? So glucose transporter 1 to 4 is specifically used for what? Glycolysis. Do you get it now? And this glucose transporter 1 to 4, they are specifically designed for specific organs. Do you get what I'm saying now? Just like GLUT1. GLUT1 can be seen in the blood-brain barrier. In the what? Blood-brain barrier. And you can also see GLUT1 in the erythrocyte. When we talk about erythrocyte, what does that mean? The red blood cells. So this is where you can see the glucose transporter 1 in the blood-brain barrier and the what? The red blood cells. You get my point now? So in the blood-brain barrier and the erythrocyte, the glucose transporter 1 is very high, but it can also be seen in adult muscle, but it is very low in adult muscle, glucose transporter 1. So glucose transporter 2 can be seen in the kidney, yes, in the liver and the pancreas. Yes, so you can see the glucose transporter 2 in the kidney, the liver and the pancreas, the beta pancreatic cell to be precise. Then GLUT3 can be found in the neuronal cells. Yeah, it is very abundant in the neuronal cells. Then glucose transporter 4 can be found in the skeletal muscles and the adipose tissue. Yeah, so these are the glucose transporter 1 to 4. I get what I'm saying now. They are specifically designed for a specific organs. Do you get? So in GLUT1 you can see it in this organ, in GLUT2 you can see it in this. So these are the glucose transporter. So these glucose transporter are present around what? Biological membranes. Do you get what I'm saying now? They are transporter of glucose. They transport glucose. They assist the glucose to gain entry into the cytosol. And if this cell is a kidney cell, then which glucose transporter will be here? It will be a GLUT2 transporter. I get what I'm saying. If this cell is a skeletal muscle cell, then the glucose transporter that will be present here is what? Glucose transporter 4. I get what I'm saying now. That's why I said glucose transporter are specifically designed for an organ. And what is their essence? They facilitate the glucose in order to enter into the what? Cytosol of the cell, where they undergo the process of what? Glycolysis. Now there's something I want to tell you that is so specific about glucose transporter 1, 3, and 4. Glucose transporter 1, 3, and 4, like I said, they are responsible for uptake of glucose in the blood. You know, the glucose is in the blood, which is the extracellular fluid. So they are responsible for uptake of glucose in the blood in these following organs. But glucose transporter 2, the period at which they can uptake glucose in the blood is most especially when there is high level of glucose. Yes, when there is high level of glucose or low level of glucose, that is when glucose transporter 2 performs its own specific function. In order to what? To carry the glucose outside the cell, which is the blood, into the cell. So these are the glucose transporter that undergo the process of what? Facilitated diffusion. And you know, during the process at which glucose wants to pass through the biological membrane and enter into the cytosol, they follows a concentration gradient. The transport of glucose follows a concentration gradient, which means that it is from higher concentration level of glucose to a lower concentration level of glucose when they enter into the cell. That tell you that in this type of diffusion, the glucose present outside the cell is very high. But when they gain entry into the cytosol, the glucose becomes very low. That's what we mean by they follow a concentration gradient. So the glucose transporter, which is the GLUT, it can be anyone. It can be GLUT1 to GLUT4. Do you get now? So they transport the glucose into the cytosol. So this is the glucose. Are you get what I'm saying now? So we now have the glucose transporter in the cytosol of the living cell, preparing themselves for the process of what? Glycolysis. The glucose present outside the cell, which is the blood, needs to diffuse into the cytosol. Because where glycolysis occurs is the what? Cytosol, which is the intracellular fluid. Yeah, let's go on. So the second transport mechanism is the sodium-dependent co-transport system. You know, if you remember when we talked about active transport, you get the active transport divided into primary active transport and secondary active transport. So under the second active transport, it is divided into co-transport and counter-transport. So in here, we are looking about the co-transport, where two molecules diffuse into the what? Cell at the same time. That is another transport mechanism. Now we have the glucose to be outside in this type of transport mechanism, also in the extracellular fluid. So once we look at how glucose diffuses into the what? Cytosol. Now let's say the glucose is not here again, and this is not GLUT. So once we look at how glucose diffuses into the cytosol with the use of a co-transport system. In this extracellular fluid, which is the blood, the presence of one cations. You get their metabolites in the blood. We call them sodium ions, Na+. Do you get now? So around this biological membrane in co-transport system, there's something we call carrier proteins. So these are all called what? Carrier proteins. Do you get it now? So it is carrier proteins that will cause the glucose to diffuse into the cytosol of the cell. How? First of all, the sodium, which is the metabolite that is present outside the cell, we bind with these carrier proteins. When they bind with the carrier proteins, they activate the carrier protein, causing the carrier proteins to function. Do you get? So when the carrier protein functions, then the carrier protein binds. It binds with what? With glucose. So when they bind with glucose, then they carry the glucose inside what? Inside the cell. I get what I'm saying? Can you see the transport mechanism? But in this kind of transport mechanism, this is co-transport system. They are against concentration gradient, which means that the glucose present here is at low level. The glucose present outside the cell is at low level. But when they gain entry inside the cell, it is at higher level. Do you get what I'm saying now? So it is from a lower concentration, which is what? Outside the cell. Then when the enter into the cell, it becomes a higher concentration of glucose, which is opposite to the one that occurs in what? Facilitated diffusion. Are you getting my point now? That is just about the co-transport system. So in co, two molecules are transported at the same time. What are the two molecules? Sodium and glucose, with the aid of what? Carrier proteins. Do you get my point now? And most especially, sodium-dependent co-transport system occur in the epithelial cells of intestine and renal tubules. Yeah, those are the major organs that undergo sodium-dependent co-transport system. But when we are talking of the major organs of the body, they make use of what? Facilitated diffusion. Now let's continue. That is about the transport mechanism of what? Glycolysis. We now have our glucose in the cytosol of the living cell, preparing for what? Glycolysis. Because glycolysis occurs in the cytosol of a metabolizing cell. Yeah, let's continue. So it will lead me to my next sequence, which is glycolytic pathway or endomeral pathway. We want to look at how enzymes, how they act on this what? Glucose that has diffused into the cell, how they break down the glucose and generate what? 2-pyruvate. That is the odd fate of what? Glycolysis. Now let's continue. In this glycolytic pathway, like I said, there are enzymes involved. In this video, I'll be talking about the first phase of glycolytic pathway, which is the energy investment phase. Do you get now? So the first one is what? The energy. First of all, let's look at those enzymes that are present in glycolytic pathway. You need to know about the enzyme present in the glycolytic pathway. So the first enzyme is the hexokinase or glucokinase. Yes. So the second enzyme is the phosphoglucoisomerase. The third enzyme in glycolytic pathway is phosphofructokinase 1. Then the fourth enzyme in enzyme pathway is aldolase. The fifth enzyme is triose phosphate isomerase. The sixth enzyme is glyceraldehyde 3-phosphate dehydrogenase. Then the seventh enzyme is phosphoglycerate kinase. Then the eighth enzyme is phosphoglycerate mutase. The ninth enzyme is the enolase, and the 10th enzyme is the pyruvate kinase. Yes, so these are the 10 enzymes that are involved in what? In glycolytic pathway or in the enzyme pathway, because it is these enzymes that will break down what is called the glucose that is present inside the cytosol, that will break them down into what? Pyruvate. Do you get my point now? So that will lead me to what is called the glycolytic or the what? Enzyme pathway. We want to look at how this enzyme break down the glucose to become what? 2-pyruvate, and this occurs in the cytosol of the enzyme. We want to look at the energy investment phase. But before I go into that, the glycolytic pathway is divided into the energy investment phase and the energy using phase. So this step 1 to 5 of glycolysis, which is enzyme pathway, is the energy investment phase. Energy investment phase. Then the step 6 to 10 is the energy yielding phase. Yes, in glycolysis, the step 1 to step 5, which is from hexokinase to what? The triose phosphate isomerase. We want to invest energy in the form of ATP. But from step 6 to step 10, we want to yield back our energy during the process of glycolysis. But right here in this video, I'm going to be talking about the step 1 to step 5, which is the energy investment phase, starting from hexokinase, which is the first enzyme, to the what? Triose phosphate isomerase. Now let's get into it. So in our glycolysis, if you don't forget, inside the cytosol of the living cell, there's presence of what? Glucose. So it is within the glucose that is where glycolysis occurs. So the energy investment phase, which is the first phase of glycolysis, occurs in this cytosol. Likewise, the second phase. So the glucose, which is our starting substrate. The glucose is our starting substrate in glycolysis. So this is CHOH, then CH2OH. So this is the structure of glucose. Don't forget that the metabolic action of glycolysis occurs in the cytosol. So everything that I'm doing here, it occurs in the what? In the cytosol of the cell. So this is the glucose now. Do you get now? So the glucose will be acted upon by the first enzyme of glycolysis, which is what? Hexokinase or glucokinase. Now, before I continue, there's something so specific about hexokinase or glucokinase. They are isozymes. When I say isozyme, it means that they have different amino acid sequence, but they perform the same reaction. What is the same reaction they perform? They act on what? Glucose. Do you get what I'm saying now? They act on glucose. That is the reaction they undergo. What makes up enzyme is protein. So their protein sequence is different, but they perform the same reaction. And hexokinase can be seen in all metabolizing cells, but glucokinase can only be seen in the liver cell or maybe in the beta pancreatic cell. Do you get now? So Those are the major differences between hexokinase and glucokinase. So it is the hexokinase or glucokinase that undergo the first substrate level phosphorylation, in the sense that they phosphorylate the glucose. You know, the glucose present in the cytosol. We don't need the glucose to diffuse out of the cytosol. So in order to trap the glucose in the cytosol, it needs to undergo the process of the what? Phosphorylation. So it needs to be phosphorylated so that it can be trapped in the what? In the cytosol, so that it won't escape the what? Cytosol. Do you get? Because those transporters that are present in the biological membrane, they can as well transport glucose back into the blood. So in order to avoid that, this glucose needs to be trapped. And what we trap it is this reaction. This reaction is called the first primary reaction that will trap the glucose in the cytosol. Do you get it now? So let's look at the reaction. So when the glucose is acted upon by hexokinase or glucokinase, this hexokinase or glucokinase add phosphate group to the carboxyls of glucose. This is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So at the carboxyls of this glucose, the hexokinase add phosphate to it. And where is the phosphate coming from? It's coming from the ATP. And ATP becomes the what? ADP. You know, the ATP is our energy. Adenosine triphosphate. So it rips off phosphate group from the ATP and add it to the carboxyls. So when it add the phosphate group to the carboxyls, the phosphate becomes reduced to what? Diphosphate. Do you get? So when we add phosphate group to the carboxyls, what we have that CHO, then CHOH, COH, H, CHOH, CHOH, then CH2O, PO3, H2. Can you see now that phosphate group coming from the ATP has been added to the carboxyls to form the CH2O, PO3, H2. The phosphate group is H3PO4. The phosphate group that is coming from ATP is H3PO4. So when you add the phosphate group to these carboxyls, water needs to be released. So when we remove OH from the H3PO4, what do we have? We have H2PO3. When you remove OH from H3PO4, you have H2PO3. Then the OH is added to this H, causing water to be released. Then you now have that CH2O, PO3, H2. That is why you have it like this. You get my point now? So this reaction, this product form is what we call the what? Glucose 6-phosphate. Do you get it now? So the first primary reaction in glycolysis converts glucose to what? Glucose 6-phosphate by adding phosphate to the carboxyls of what? Glucose. Now we have the glucose 6-phosphate. So the glucose inside the cell, cytosol, has been converted to glucose 6-phosphate. So the glucose 6-phosphate can never leave the cell because it has become phosphorylated. We have now trapped glucose. We have devised a method to trap glucose, converting it to what? Glucose 6-phosphate. And you know, the glucose 6-phosphate is two polar, and it cannot diffuse through the lipid core membrane, or it cannot diffuse through the lipid core of the cellular membrane. So it remains in the what? Cytosol. And adding phosphate to the glucose makes it kind of large, and there's no transmembrane carrier protein for what? Glucose 6-phosphate. So it remains in the cytosol for the process of what? Glycolysis. Now let's continue. So this is the step 1 of glycolysis. And there's something called cofactor. Do you get? It is assisting the hexokinase to perform this reaction. Do you get? It shoots the negative charge coming from the phosphate group so that it will not destabilize the structure while adding phosphate to the what? Glucose. Now let's continue. So that is step 1. So step 2, the product of one step is the substrate of another step. So in the step 2 now, this will be our what? Our substrate, where the second enzyme of glycolysis will act upon. So let's join. So this CHO, CHOH, COH, CHOH, CHOH, then CH2O, PO3, H2. So this is what? Reversible. Don't forget that step 1 is what? Irreversible. It means that the arrow is pointed forward. Do you get it? It is an irreversible reaction. But in step 2, it is a what? A reversible reaction. Do you get it now? So the enzyme here is the what? Phosphoglucoisomerase. So what we phosphoglucoisomerase does? No, isomerism. What is an isomer of glucose? Fructose. So the difference between glucose and fructose is that glucose has an aldehyde, while fructose has a what? Ketone. So this enzyme will catalyze the change of this functional group, converting this functional group, which is aldehyde, to become ketone. So it will convert this function to become fructose. And you know fructose is CH2OH, C double O, COH, H, CHOH, CHOH, then we have the CH2O, PO3, H2. Can you see now? This is our glucose. Sorry, this is our glucose 6-phosphate in the step 2 of glycolysis. Then phosphoglucose isomerase convert this glucose 6-phosphate to become what? Fructose 6-phosphate. Fructose what? 6-phosphate. You get my point now? So it catalyzes the change of this functional group. In glucose, the functional group is aldehyde. So the aldehyde is converted to ketone, which is at carbon 2, causing the glucose 6-phosphate to be converted to what? Fructose 6-phosphate. So that's about what? Step 2. Now let's continue. Let's move to the what? Step 3 of glycolysis. Don't forget that the product of one step is the substrate of another step. So what is the product here? Fructose 6-phosphate. So it will be the substrate of step 3. Now let us draw the fructose 6-phosphate. So this is the fructose 6-phosphate. So this is the step 2. So the step 3, we have the CH2OH, C double O, COH, H, CHOH, CHOH, CH2O, PO3, H2. So this is what? Fructose 6-phosphate. Fructose 6-phosphate. So this fructose 6-phosphate will be acted upon by an enzyme. That's what we call phosphofructokinase 1. Anywhere near kinase, what does that mean? It's either they remove or they add phosphate. But right here in the step 3 of glycolysis, the phosphate is also added. Then where is the phosphate coming from? Just like step 1, it is coming from the ATP. And the ATP becomes the what? ADP. So the phosphate is added to carbon 1 of this fructose 6-phosphate. Just like phosphofructokinase 1 is telling you that the phosphate is added to the carbon 1 of glucose. Of what? Fructose 6-phosphate rather. So when the phosphate group is added to the carbon 1 of fructose 6-phosphate, what will it form? Then it becomes CH2O, PO3, H2, then C double O, COH, H, CHOH, CHOH, CH2O, PO3, H2. Now, can you see now that phosphate group has been added? The phosphate is coming from ATP. So the phosphate group is added to the carbon 1 of fructose 6-phosphate to form what? Fructose 1,6-bisphosphate. Bis what? Phosphate. You call it bisphosphate. Do you know why it's called bisphosphate? Because the phosphate group is far away from each other. The phosphate group is at carbon 1, this carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So the phosphate group is at carbon 1 and another phosphate group is at carbon 6. You get it? That's why it's called fructose 1,6-bis. Normally it should be bi, which means 2-phosphate. But it's called bisphosphate because the phosphate group are far away from each other. So when the phosphate group are far away from each other, you use the word bis and not bi. Do you get it? So that's about step 1. Step 3. Step 3 of ending Mayoff pathway. Now, the next step will be step 4. You know, I've told that the product of one step is the substrate of another step. Now, step 4. So this is our substrate now, is step 4. So that is CH2O, PO3, H2, then C double O, COH, H, CHOH, CHOH, and CH2O, PO3, H2. So this is our fructose 1,6-bisphosphate. So in the step 4 of the Mayoff pathway, it is also what? Reversible. Step 3 is what? Irreversible. Now step 4 is what? Reversible. So which enzyme will act on the fructose 1,6-bisphosphate? It is called what? Aldolase. The aldolase is the 4th enzyme of the Mayoff pathway. So what will aldolase do? The aldolase will undergo what is called splitting. Do you get? It will split this carbon molecule, this is carbon chain, and divide it into trios. When I say trios, it will divide it into 3 carbon molecules. So it's going to break the bond between this place. I get what I'm saying now. So when it breaks the bonds, what do you have? You have this part here, which is CH2O, PO3H2. Then followed by C double O, then COH and H. Then this second bond is what we call the CHOH, CHOH, and CH2O, PO3H2. Do you get now? So the hydrogen splits the bond here, dividing it into 3 carbon molecules and 3 carbon molecules. So this is the first 3 carbon molecule, which is here, and this is the second 3 carbon molecule, which is here. Now this first 3 carbon molecule is not stable. Likewise, the second one. So during the process, the second carbon molecule, which is this 3 carbon molecule, it will give this hydrogen to this place. So when you give the hydrogen to this one becomes 2 hydrogen. Is that not true? Then that's CH2OH. So this now can be written as CH2OH. Then this one, the hydrogen that has been given to this, it is not there anymore. So this one is now CHO. That's why it's CHO. So this first 3 carbon molecule is what we call dihydroxyacetone phosphate. While this second carbon molecule is what we call the glyceraldehyde 3-phosphate. So that is about step 4 of glycolysis. Do you get it now? Now in step 4, fructose 1,6-bisphosphate has been converted to 2 trios. The first trios is the dihydroxyacetone phosphate. They call it DAP. And the second one is the GAP, glyceraldehyde 3-phosphate. So that's where the splitting of glycolysis starts from. So that is why during the process of glycolysis, you have the product becoming 2. Yeah, it's a result of the splitting that occurs here. So let's move on. The last one for this video is the step 5 of enzyme pathway. So this will be our substrate in step 5. These 2 products that is present there will be our substrate. So what are the 2 products? CH2O, PO3H2, then followed by C double O, CH2OH. This is the dihydroxyacetone phosphate. Then the second one is CHO, CHOH, then CH2O, PO3H2. So this is the dihydroxyacetone phosphate, and this is what the GAP, glyceraldehyde 3-phosphate. So the next enzyme that will act upon it, this step 5, is also reversible. Do you get? So the next enzyme is the triose phosphate isomerase. So the triose phosphate isomerase will only catalyze this gap to become the gap. It will convert the dihydroxyacetone phosphate to become glyceraldehyde 3-phosphate. So this one will be converted to this. So this one will be what? CHO, then CHOH, then CH2O, PO3H2. So this is the one glyceraldehyde 3-phosphate, the gap. Then this gap will still remain the gap. And this is it, CHO, CHOH, then CH2O, PO3H2. Now, can you see now? We have 2 glyceraldehyde 3-phosphates because the triose phosphate isomerase will convert the dihydroxyacetone phosphate into the gap, which is the glyceraldehyde 3-phosphate. So this one has been converted to this, and this one is here. So you have 2 of these glyceraldehyde 3-phosphates that will continue the process of what? Enzyme of pathway. Do you get now? So the summary of this reaction is that in glycolytic pathway, you get. So we know that in glycolysis pathway, let me use this. So in the process of glycolysis, just the summary of the energy investment phase. That's what I want to look at. The glucose. Let me use this. The glucose is converted. Yeah, the glucose is converted to what is called glucose 6-phosphate. What's the name of the enzyme? hexokinase or glucokinase. So the ATP is used up, which got converted to what? ADP. That's for the step 1. Now in step 2, which is reversible, which enzyme act upon it? That is the step 2 enzyme of glycolysis. That is the phosphoglucosisomerase. You get? So the phosphoglucosisomerase will convert glucose 6-phosphate to what? To fructose 6-phosphate. So this is the step 2. Yeah, this is step 1, this is step 2. Then the step 3, which is also irreversible, will be acted upon by phosphofructokinase 1. Then convert ATP is used up, like I explained. Then fructose 6-phosphate will be converted to what? Fructose 1,6-bisphosphate. That's for step 3. Then step 4, which is also reversible, will be acted upon by agonist. Then it will break the bond and convert it to what? Glycerol 3-phosphate and dihydroxyacetone phosphate. The gap and the gap. Then for the last step, which is step 5, which is also reversible, will be acted upon by the triose phosphate isomerase, whereby the gap will remain the gap and the gap will now become the gap. So you have 2 glycerol 3-phosphate at the end of energy investment phase. So it is these 2 glycerol 3-phosphate that will continue the step 6 to step 10 of endometrial pathway. So why it is called energy investment phase is that in the step 1 of glycolysis, you make use of 1 ATP. Then in the step 3 of glycolysis, you make use of 1 ATP. So how many ATP have we used up? We have used up -2 ATP. That is why it is called the energy investment phase. Now we are done with the energy investment phase. So we have the glycerol phosphate and the glycerol phosphate, which will continue the energy building phase or the payoff phase. Now we have come to the end of this video. Please don't forget to like and subscribe. Peace out.